When the convection currents from Earth's interior are converging, we get a convergent boundary. The first one we're going to look at is Oceanic Continental. In the last video, we talked about how the Atlantic Ocean is growing in size. If that's happening, then why isn't this globe getting bigger? Why is the Earth not growing? And to answer that question, that brings us to convergent boundaries. Because what's happening, if we look at the Pacific Ocean, where the continents are actually moving closer together. And the reason that happens, when an oceanic plate or an oceanic crust and continental crust come together, the oceanic crust that is more dense is going to push underneath that continental crust. And that process is called subduction. Remember, the prefix sub means under. The oceanic crust is getting pushed under. Now, when that happens, this part of the crust is cool. This part of the crust is warm because you've got the friction of these rocks that are rubbing against each other. Also, you've got some dissolved gases that actually raise the melting point. So these rocks down here are actually pretty hot. So what that does is it melts the rock. Well, melted rock is less dense, so it's going to start to rise. When it does, Thank you. Put it right there. What we see are volcanoes that form on the continental crust. These are called continental volcanic arcs. An example would be where the Pacific plate is pushing underneath the North American plate, the Cascade Mountain Range. That's where Mount St. Helens is. It's one of these volcanoes. Also, where the Pacific plate is subducting underneath the South American plate, we have the Andes, another mountain range. All right. Now, if I have an area where two oceanic crusts are being pushed together, whichever crust is older, it's going to be a little more dense because the rocks are more compressed. And the same thing happens. Part of the oceanic crust subducts under the other. The friction creates heat. We're melting rocks. And we're going to create what is called a volcanic island arc. So these are volcanoes that form on the ocean floor. If they get tall enough, they're going to go above the surface of the ocean. The island of Japan, or the islands of Japan, would be an example of an oceanic subduction zone. The Aleutians, the island chain that goes off of the end of Alaska. If we look at our globe, the Aleutian Islands actually go off the tip of Alaska, across the international date line. It's a very long island chain, and that's where one plate is subducting under the other. And Japan was the other example. So if you look all around here, those are oceanic convergent boundaries. Whereas all around the edge of our continents are continental convergent boundaries. So the Pacific Ocean is actually getting smaller in size because that oceanic crust is subducting below the other crust. All right, now occasionally we'll have continental boundaries, and what happens there, because the density is less than that of oceanic crust, and neither one is going to be enough of a difference for one to subduct under the other, they push together, which causes that crust to become thicker. So part of it gets pushed up into the atmosphere, part of it gets pushed down into the mantle. This is what is happening in between India and the rest of Asia. So let's look at our globe once again. India is pushing up into Asia, and that forms this mountain range right here. Those are the Himalayas, where Mount Everest is. Mount Everest actually grows in height, as well as the other mountains of those areas, because those continents are squeezing together. Now, when these two pieces of continental crust push together, we get folding and faulting. You can see this. Folding, rocks are going to undergo stress, and up until a certain point, they're going to be able to fold and bend. Eventually, they can't stand the stress, and they will crack and break. When a rock cracks and breaks, that's a fault. So if you see these mountain ranges, they're going to have lots of folds because of the stress of those two pieces of crust pushing together. So those are our three types of convergent boundaries.